Welcome back. This is the pressure systems lesson. We're still on the EEN 2.5.2 objective, explaining formation of typical air masses and the weather systems that result. Last lesson, you got a quick understanding of what a air mass is and how it forms. So you've got the explanation part of the typical air mass. But now we have to talk about the systems that those air masses create. So we're breaking this objective apart. We've talked about the typical air mass formation. Now we're going to talk about the weather systems. And then the next lesson, we're going to talk about how those weather systems interact and then the things that happen because of that. That's the results. So let's get into pressure systems. So basically, what is air pressure? Okay, we've talked about this a little bit just in passing. But really, what it boils down to is the air pressure is the effect of the atmosphere pushing down at ground level, at sea level. It's always discussed based on surface pressure at sea level. 0 feet altitude. Now here in Cabarrus County, we're about 900 feet above sea level. So that affects our air pressure a little bit because we're a little higher up. And if you remember back to the layers of the atmosphere, the further up you go, the less the pressure is. So we lose a little bit, not enough to really make a difference at 900 feet. But we use 0 feet as the guide. Why? Well, air pressure at sea level changes very little. So when I say it changes very little, let's talk about how it's measured. So many scientists measure air pressure in what's called a kilopascal, KPA. However, if you watch TV or you go online and you look at weather maps, which I love to do, TV meteorologists and amateur meteorologists, that would be you and me, we measure air pressure in inches of mercury. Okay? So we're not going to get into the details of how the barometer measures in inches of mercury. If that's something you're interested in, you want to look up mercury barometer, and it'll really make a lot of sense once you understand that. But let's just talk about the basics. The basics are this. At sea level, the minimum air pressure, the lowest the air pressure can get, is 26 inches of mercury. 26. The maximum ever recorded was 32.06 inches of mercury. So that's the range that we're working inside of, 26 to 32. Now, in reality, if you spend some time looking at air pressure maps, which we're going to do today, you're going to notice that the pressure actually doesn't range between 28 and 31. That's really the range that we look at. But for scientific purposes, we say the minimum is 26 and the maximum is 32.06. And that's not just saying that's as high as it'll go. That's just saying that's as high as we've ever recorded. So it possibly could have gone higher, but we haven't recorded that, so they're not using that. So what are air pressure systems? We've talked about air masses and how they're formed. Now let's talk about how the air pressure system forms. So we've got a high pressure system and we've got a low pressure system. Well, what are some of the things that can cause change in these pressure systems from high to low, from low to high? Okay, temperature changes in the atmosphere. So the warmer it is, the warmer the air gets, the more of an effect on whether it's a high pressure, low pressure system. If that air mass is over water, so the temperature of the air compared to the temperature of the water can cause the pressure either to go up or to drop. Any upper level disturbance, when we say that, we mean cyclonic motions. That means the atmosphere going in a circle, tornado, think tornado or hurricane. Okay, that's an upper level disturbance that comes down to the ground on occasion. Cyclonic motions happen all the time. It's just we don't notice them until they come down to the lower level. They're usually upper level. The jet stream, we'll talk a little bit about the jet stream probably tomorrow. And then pockets of cold air. If there's a dense pocket of cold air, that can affect a high pressure or low pressure system. Solar heating, that's the sun heating the air or heating water up, which can cause changes. Or radiative cooling, And that's just a fancy way to say, we talked about how the sun can warm stuff up. Well, when the sun goes down, the pavement radiates. You can look at a piece of pavement after it's been in the sun all day, and you see those shimmers. That's radiation. It's the heat that's stored into that road or that concrete, and it's giving it off because the air is now cooler. So all of these things can affect the air pressure systems. So the high pressure system, the low pressure system can be affected by these things. That's just basic information. You don't have to memorize all of that. That just helps you to understand the different things that can cause a change. Now that's important because those things, some of those things can work by themselves to cause change. Some of those things work together to cause change. So it's just understanding that there's a whole lot of different pieces to this puzzle. Basic idea is this. Pressure systems, high pressure and low pressure, is what causes your local weather. So for today we had rain, and I'm going to show you some weather maps from today. Today is May 29th, so this is Friday that I'm recording this for Tuesday's lesson. So we're going to actually look at some maps that are on for Tuesday. So let's talk pressure systems. The low pressure system. What does that mean? Well, the aspects of the low pressure system are generally there's clouds, and usually there's precipitation when there's a low pressure system. Usually. Clouds and precipitation. Well, what effect does that have? Well, you tend to have cooler temperatures or smaller temperature changes. So if it's cloudy and it's raining, you're probably not, like right now it's 74 degrees. And it's been raining most of the afternoon. So it's cloudy. It's been raining. It's about 74 degrees. It's not going to go up into the 80s today. It's not going to go up into the 90s today. The low temperature is 64. So 74 is our high. 64 is our low. We've only got, in this case, a 10 degree temperature change. Okay. So on cloudy, rainy days or cloudy and snowy days, the differences between the high temperature and the low temperature are smaller. The pressure, if you were to actually measure the pressure of a low pressure system, most of the time it's going to be between 29 and 30 inches of mercury. And then on a weather map, that low pressure system is indicated by a red L. Okay? Now let's look at a high pressure system to compare it. So aspects of the high pressure system. Clear skies, little to no precipitation, and then if we take that into account, thinking about what was going on with the low pressure system, we actually have more temperature change. So during the day, there's no clouds, there's no rain, so the sun heats the ground up, and it'll go up to 80, 85, 90 degrees. The sun goes down, the pavement and the surrounding items give off their heat, and by first thing the next morning, the temperature's down to 60 or 55 degrees. And we've got anywhere from a 20 to 30 degree temperature change from morning till night. That's usually in a high pressure system. And then high pressure is usually between 30 and 31 inches of mercury. And that'll mean more in a minute when we look at the maps. On a weather map, high pressure systems are indicated by the blue letter H. So, what do high and low pressure systems look like on a map? Well, let's look at these maps. So this is the first map that you're probably familiar with. I got this map from Weather Underground, W Underground, well, I call it wonderground.com. It's one of my favorites because it's one of the few websites and apps that you can use that can pull up these weather, the frontal systems, the low pressure, high pressure systems. It's one of the few that you can pull this up and look at it without having to pay for the app. So that's part of the reason why I use Weather Underground for this particular map. So just like we had talked about, you can see the red L's, you can see the blue H's. So you know where the low pressure systems are, you know where the high pressure systems are. Now, usually, not always, usually where you see a where you see a red L, you can usually guarantee there's going to be clouds and rain. Okay? Usually. And usually where you see a blue H, you're going to see clear skies and little to no precipitation. Now, the exception is right here in the middle, right near Tennessee's, North Carolina's border. You've got that blue triangles, and then you got those red half circles, and you got that H stuck in the middle there. This is a unique situation, so this isn't gonna be normal. We'll talk about how this affects each other tomorrow's lesson. We talk about the effects of the high pressure, low pressure systems interacting with each other. So, but just generally, anytime there's a red L, there's going to be clouds and rain. Anytime there's a blue H, it's going to be clear skies and no rain. Now, this is one way to look at pressure systems. So we can look right at it and we can say, okay, blue L, that's low pressure system. Red H, or blue H, that's red L, low pressure system. Blue H, high pressure system. Easy to see, right? Well, this is another pressure measurement map. Okay, now I got this one from weatherbug.com. And on this one's a little harder to read. Remember what I said about low pressure systems being between not 29 and 30 and high pressure systems being between 30 and 31. Well, if you remember, right here was that high pressure system between 30 and 31, right? Okay, and if we come back, we can look over here. San Francisco has a low pressure system. So if we look right here, you see it's in the 29s. Right there's even lower, the lower part of 29. Okay, if we come back here, there's a low pressure system up here in Quebec. So if we come back here, you can see these in Quebec. They're all in the 29s. Okay, so this map is a little harder to read. You really have to look closely. You really have to pay attention. But there's a third map. And all of these maps are pulled from today, May 29th, because today we've got that rainstorm coming through, and it's a really good day to pull weather data. So this one, I like this one of all of them, because what this does is it shows you here at the top, right here, it shows you the measurements and the colors. So if it's in the oranges or the dark browns, the oranges are the 28ths. And as you work up into the dark browns and the burgundies, you get 29. And the greens, 29.5 to 30. And then if you get into the blues, are right about here. And then the pinks. And then the bright pink. So you can look at this map. And based off of this map, you can say, okay, this area here, low pressure. This whole side has got low pressure all over it. You got big high pressure right here in the middle, and you got a fairly good high pressure right here. Well, how accurate is that? Low, 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 big low up here, highs in the middle, and then a fairly good high right here. See how this says the same thing as this and says the same thing as this, but this is a whole lot easier to read. So these are your pressure systems, okay? Now, I'm going to have you work on a check-in for pressure systems. I want you to go ahead and do that pressure system check-in. It's going to have a couple of maps up there. I want you to read the maps, give me that feedback on whether you think it's a high pressure system or a low pressure system. And based off of what we've talked about so far, do you think it's going to be cloudy or clear? Whether you think it's going to be raining or not. Okay? So that's what I want you to be working on next. If you have any questions, please come see me on Microsoft Teams. Also, if you don't score 80% or higher, then you need to go back and rewatch this video. Send me a message and I'll set it up so you can retake to get an 80% or higher. If you have any questions, come see me. Otherwise, have a great afternoon.